All right, Titans, it's time for the last lesson of the week. We're going to review absolute value equations, graphing and solving, and then solving inequalities as well. Before I started filming this video, my son Calvin came over to me and he said, "Dad, can I have a bookmark?" I said, "Calvin, you've known me for 8 years. My name's not Mark." That was bad. That was real bad. That's okay. This is our last video because Mr. Wood's going to do the videos next week because we're going to do stats and that's his specialty. So I just want to say thank you for putting up with my videos and my jokes. I hope the lessons have made sense. I've tried to make them as easy to understand as possible. Hope you guys are doing well and continue to do well. And hopefully we'll get to see you back in the classroom next year. But anyway, on to some review. Graphing. First thing we have to find is our vertex. So opposite of -1 is a +1, and then our value at the end is our y-coordinate. So we know our vertex is at +1, -5. And then with graphing absolute value, we know we're going to get two lines, or two line segments. And we know that the slope of the right side of the line will be a +2, which means from the vertex, I'm going to count up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. And then we just reverse it to get the mirror image. So we're going to go up 2, backwards 1, up 2, backwards 1, etc. And that is how we graph an absolute value equation. Find the vertex and then use the a value to tell you how much to rise and run. One way to double check it, since this is a positive, our graph should be opening up, which our graph does open up. The domain of all functions, unless we're looking at context of a problem like we did last week, that's different. But if we're just looking at a function for absolute value, domain will be all real numbers. But it will have a specific range because we have, in this case, a minimum point. So the lowest y value we reach is -5. Which means the y values on the graph are all greater than or equal to that -5, so we never go below -5. This definitely has a minimum. Interval of increase, we go to our axis of symmetry, and the graph is increasing to the right of that, so to the right of +1. So as we go from 1 to infinity, the graph continues to increase. So from 1 to infinity, which means it's going to decrease the other half of the graph, which goes from -infinity to +1. So from -infinity all the way until we get here to +1, that graph is going down. One more example of graphing. Again, we need to find our vertex. There's nothing added with the x, so that means our x-coordinate of our vertex is 0. And then we do have a +4 at the end, so it will move up 4. So our vertex is right here at 0, 4. We then look at our a value, which is -1. Because it's negative, we know it's going to open down, so it's going to, instead of a V, it's going to look more like an A. And we know since our a is -1, we're going to go down 1 for every time we go over 1. So our slope on the right half of the graph is -1. And then to get our mirror image, we're going to do the opposite. We're going to go down 1, backwards 1, so that we get a nice symmetrical linear absolute value graph. Our domain goes forever left and right, so all real numbers. Our range, the highest y value we reached was 4. We never go above 4. So all the y values on the graph are less than or equal to that 4, because the 4 was our maximum, which means every other y value will be smaller or equal. Interval of increase. This time when we look at our graph, the side that's increasing is the left side, and we always look at our x value. So if we go as far as we can left, this is -infinity, and as we move towards 0, as we go this way, our graph is going up. So it is increasing from negative infinity until we reached our line of symmetry, which was an x value of 0. But once we reach that x value of 0, as we move towards positive infinity, where's our graph going? It is going down, so it is decreasing from 0 to positive infinity. Okay, so that was our review of graphing. Absolute value equations, these are where we want to make sure the bars are alone, and then we set up two problems. So this one, the absolute value is by itself, and it's equal to 13, so I'm going to do 3x minus 8 equals negative 13, and 3x minus 8 equals positive 13. And then to get our solutions, we'll solve each of those equations. This one's going to give us a fraction. That is perfectly fine. If you prefer to turn it into a decimal, negative 5/3 is the same as negative 1.67. And then for the second one, 3x equals 21, which means 1x will equal 7. So again, make sure the bars are alone. Set up your two problems. We want our absolute value to be 13. So the two numbers that have a distance of 13 are negative 13 and positive 13, which is why we set our equations equal to those. And then we solve. This equation does have some numbers outside of the bars, so we do need to get rid of those first. So I'm going to subtract 3. Then to get rid of the 4, I'm going to divide by 4. And I end up with the absolute value equal to 5. So to have an absolute value of 5, we can set one problem equal to negative 5, and we set our second problem equal to positive 5. Solve them. One solution is negative 4. And our other solution is positive 6. So again, absolute value typically has two solutions because there are two different ways to be the same distance from 0. If there are negatives in the problem, we just have to be careful. This one is saying that our distance from 0 is negative 13, but our distance will never be negative. So this one is no solution. But this final example, it is equal to negative 2, but this one is not no solution. And the reason is before we decide if it's going to have solutions or not, we need to get the absolute value by itself. So when I add the 10 right here, we actually get an equation where our absolute value is equal to a positive 8. So we can have a distance of 8, so we can solve this. To have a distance of 8, we can either be at negative 8 or positive 8. So now solve each equation. X can equal negative 7, or x can equal positive 9. Again, to check our answers, we could plug them in. For example, if I plugged in 9, 9 minus 1 is 8. The absolute value of 8 is 8. And then 8 minus 10 is negative 2. It works. Negative 7 would also work, I promise. Okay, the third day of the week, we worked on solving absolute value inequalities. So again, inequalities means we're dealing with the inequality signs, such as less than, greater than. Right? We can also have the equal to in there. And this is where we have lots of answers because we're not just equaling the number, we need to find all of the values that are greater than or less than. So there's a lot. This particular one, we're going to start by setting it equal. So we're going to solve it like an equation to start. So I'm going to set up my two problems. I'm going to do x equals negative 9 and x equals positive 9. And when I solve it, what I'm really finding for the inequality is my boundary points. So on my graph, I can put a point at negative 9, and I can put another point at positive 9. So by solving the equation part, I get my boundary points. Then we go back to the inequality and we have to decide two things. Do we shade in our circles, and which direction do our arrows go? So first I look and I notice that this does not have an equal to. So -9 and +9 are not solutions, so we will not shade those in. Second thing I notice is that my absolute value is less. So my distance is less. How do we make our distance become less? We go towards each other. If we go towards each other, then our distance is becoming smaller. So we're going to have these 2 points go towards each other, and all of our solutions will be all of the points in between -9 and +9. So our solution we write as x is less than 9, right? It's less than 9, but it is also greater than -9. So anytime you have a problem where it's connected in the middle like this, we can write it as one compound inequality. The second example, if I set them equal to each other, kind of like we did on number 1, I can do x equals -11, x equals +11, right? My two separate equations, which tells me that my two boundary points will be at -11 and +11. Bless me, thank you. But now when I look at my inequality sign, I notice it says I can equal. So because I can equal those, I'm going to circle in or shade in my boundary points. And then this, if I read it, says the absolute value is greater than or equal to. So our distance is greater than or equal to. If we want our distance to become bigger, we get away from each other. So these 2 points, in order to increase their distance away from each other, they're going to get away. They go away. So by doing this, now instead of having one graph where they're all together, we have 2 separate graphs that show us all of the possible solutions that we could plug in. And so we're going to write it as 2 separate sets of solutions. We have all numbers or all x's that are less than or equal to -11. Or we also have all numbers or x's that are greater than or equal to +11. So this is our solution set. This would be the graph of our solution. And we are done with that. All right. Last set of examples, keeping it short today. With absolute value inequality, sometimes there's a little bit more going on than just an x. So first thing I look for is to see if there's anything outside of the bars, which there are not. So I'm going to solve this as though it were an equation. So to have an absolute value of 9, we could be at -9, or we could be at +9. And I'm going to solve these to be able to get my boundary points. One of my boundary points will be at -2. My second boundary point will be at +7. So when I go to draw my graph, I'm going to have one point at -2 and another point at +7. And then I go to my inequality and it is not equal to, so I will not shade in my boundary points. And this says that my absolute value is greater. My distance is more, it's greater. So to increase our distance, we get away. So we're going to go away from each other, which means our solution set will be all numbers that are less than -2, or all numbers that are greater than +7. All right, last example. Before I can set up my 2 problems, right, because I'm going to treat it as an equation to start. Before I set up my 2 problems, what do I need to do? I need to subtract 3 from both sides. We need to get the bars alone. So now we have absolute value of x minus 4 less than or equal to 8. Now that the bars are alone, there's nothing outside, we can split it up into the two problems. X minus 4 equals, to get an absolute value of 8, we could be at negative 8 or positive 8. So we set up both of those equations. And then we solve them. X equals negative 4. X equals 12. So again, when we solve it, we are finding the two boundary points for the graph. We'll have a boundary point at negative 4 and a boundary point at positive 12. And this time when I go back to the original inequality, it can be equal because we have the line underneath, right? The line underneath means it's less than or equal to. So I can equal my boundary points. I'm going to shade in my circles. And then finally, to determine if we go away from each other or towards each other, this says that the absolute value is less than or equal to. So our distance, we want it to be less. So to make our distance less, we go towards each other. We're going to get closer, come together. And so our solutions, our x's, our solutions, are going to be all of the numbers between negative 4 and 12. So we are going to be less than or equal to the 12, but we are going to be greater than or equal to the negative 4. So this would be our solution. This would be the graph of our solution. And this would be the work that we did to get there. Again, I know this has been kind of a crazy semester. Appreciate you guys putting in that hard work at home, coming on Zoom, asking questions, getting the help you need. Hope that you keep persevering. Good luck next week with the statistics. Mr. Wood is an expert at that. He teaches the AP class on campus. I think you'll find that the stat stuff is really quite cool and pretty interesting, and maybe you'll end up taking Mr. Wood for stats down the road. Anyway, go Titans. Hope you guys are well. Keep it up. Have a wonderful summer. We'll see you guys soon.
Bye. Forever.